Unfortunately, or fortunately, depends on how you look at it, we ended up taking 6-7 over a couple different lessons anyway, or lesson videos anyway. Just couldn't, a lot to do within that first little section. There's a lot to do within this little section that's going to be new. So we spread it over a couple days, so that's going to push some things back, but that's okay. Sometimes you got to take a step back and get the information out to you and make sure that you guys are good to go with it. So moving things back a little bit, maybe a day, but oh well, it's the way it is. So we just got done talking about geometric series or sequences in the last video, and today we're going to look at geometric series and how we go about finding the sum of geometric series in a bunch of different ways, and then finding values of n values and doing those different types of things, and kind of bringing logarithms into play here towards the end of the lesson. So first and foremost, the general formula for finding the sum of what we call a finite geometric series. So a geometric series is the sum of the terms of a geometric sequence. So a sequence is what we are working on. It's just a sequence of numbers, 2, 4, 6, 8, 10, blah, blah, blah. That's not geometric, but 2, 4, 8, 16, so on. There's a geometric sequence. A series is when you take all of those numbers within a certain sequence and add them up. So if you think about it, if we're just looking at a geometric sequence, and I have that sequence 2, 4, 8, 16, and 32, if I want to know the sum of that sequence, well, technically speaking, I could just take this sequence and add all the numbers together with my handy-dandy calculator, and I could add them up, 2 plus 4 plus 8 plus 16 plus 32, and I get this is equal to 62. So I could say the sum of the 1, 2, 3, 4, 1, 2, 3, 4, 5, the sum of the first 5 values of this sequence is 62. Okay, so when you're doing geometric series, you can just add all the different numbers that you have within that sequence. Now, within this, there are a couple things we have to know. S of n. S of n represents the sum of the geometric sequence with that term. So in the last one, I found S of 5. I found the sum of the first 5 terms of that sequence that I gave you. Just like A of n meant the value of that term in that sequence, S of n means the value of the sum of that many terms. Okay, so it's this whole drawn out thing. Now, we can find the sum of a finite geometric series. Instead of adding them up all the time, there is obviously a formula for this, and this is the formula that we are going to use. This S of n is equal to, so the sum of the nth terms is equal to A1 times 1 minus your r to the n, all divided by 1 minus r. Now, r, again, is your ratio, and n is, the number of terms that you are finding the series of. Okay, so again, you're going to highlight this, you're going to put a star by it, you're going to do whatever you need to do, and this is how you find the sum. S of n means finding the sum. And we're going to use this formula to find various things. And not only are we going to use it to find the sum of a sequence, of a geometric sequence, but we're also going to use it eventually to find that nth value and pull in some logarithms in here. So let's start out with a couple of basics. I already gave you the answer here already, but we're going to evaluate each geometric series kind of as described. So we've got this geometric series, and we want to know the sum of this case of the first 6 terms. And I gave you the answer already. So we're going to find the sum of n, but we know what that is in this case. We know our n value that we're given is 6. So we're going to find the sum of the first 6 terms. So our formula says the sum of our first 6 terms is going to be our first term, which they gave it to us already. And I'm looking over here, and as you guys were writing the formula down, I wrote it over here. Okay, it's not something I remember either, so I've got it kind of sitting over here at the side. That's what you've seen me doing when I was kind of going through it before. It says my first term, which is 4, times 1 minus my ratio. Well, what's my ratio? I go from 4 to 24 to 144. So if I go 24, clear, 24 divided by 4, that's 6. Just to double check, 144 divided by 24 is 6. So my ratio is 6. So it's 1 minus 6 to my n value. My n value is 6. They gave that to us. It's right there. It's right there. All divided by 1 minus 6. Okay, so I'm going to plug into the handy-dandy calculator. So I'm going to go 4, and I'm going to put a parentheses. 1 minus 6 raised to the 6th. Now I'm going to close the parentheses. I'm going to divide it by, I'm assuming you can do 1 minus 5 on your calculator, or 1 minus 6 on your calculator. That's negative 5. And hit the enter button. And when you hit the enter button, you get 37,324. Okay? There's the first one. Okay, you're kind of given what you need. Okay? Go ahead and do number 10. See if you get the same answer. Make sure you can put this in on your calculators. Obviously, you got to be really careful with this one. It's negative 3, and then you have to put the parentheses in your calculator, and I would do it just how I did it up there. 1 minus, and then put a parentheses, minus 6, close parentheses to the 6th power, close parentheses, and then divided by, and then you can do 1 minus negative 6. But again, it's at minus negative 6, so remember sure you divide by 7 in here. And you're kind of paying attention to that. So make sure you get that answer before you go on. So your habit's going to be to move on, but make sure if you're going to use your calculator to do these, that you can use your calculator to do these, because it's easy to make little errors in here, like, dividing by negative 5. Not putting that negative 6 into parentheses is going to cause you issues. So make sure you can do these with the calculator. The next type of problem then, really even a little bit less to kind of figure out. And this next type of problem, and I'm just doing these because this shows up in your assignment, and we're just going to do one of these. But again, you're going to evaluate, you're going to do the same thing, same directions, evaluate each geometric series as described, but now you're given the A1 value, you're given the R, and you're given the N. So you don't have to find the R in this case, so it's obviously even a little bit easier. So we're going to find the sum of the first 8 terms. So S of 8 is going to equal our A1, which is 4, times 1 minus our rate, so that's negative 3, to the 8th power, all divided by 1 minus negative 3. Okay. So they gave us everything this time. We didn't have to find the rate. They gave that to us. So we've got negative 4, parentheses 1 minus parentheses negative 3, close parentheses raised to the 8th, close parentheses again. Take that and divide that by 4. And you get 6,560 for your solution for that one. Okay, straightforward, that one. If you want to do the second one real quick, you can do the second one. Real quick, I'll throw the answer up there. I'm not even going to show you how to do it. I'll just kind of throw the answer up there to make sure you got what you need for the answer. So you should have got negative 39,063 I believe. So that's finding, the sum of this certain sequence. And now the next thing we're going to look at is we're going to look at evaluating geometric series as described, but now we're going to come up along with what's called sigma notation. Okay, so we're going to watch a video. I'm going to blank out myself here. You're going to watch a video on how to do this. She's just going to talk about sigma notation. Let somebody else do it other than myself. You can listen to her, and then we'll come back and look at these two examples.
Let's evaluate this geometric series. If we take a look at what we've been given, we can see that we're dealing with sigma notation. Sigma notation is just a shorthand way to write a series. Here, we can see that n goes from 1 to 8. N is the number of terms that we're dealing with. And when we're dealing with an infinite geometric series, n goes from 1 to infinity. But that's not what we have. We have that n goes from 1 to 8. So here, because n goes from 1 to 8 and not 1 to infinity, we're dealing with a finite geometric series. We're trying to find a partial sum. Here, we're just trying to find the sum of the first 8 terms of this geometric series. Now to do that, we could use what we have here to find the first 8 terms and then add them all together. But that might take a bit of time. Luckily, we have a formula that can help us make this process a little faster. So let's go ahead and take a look at the formula for finding a partial sum of a geometric series. It looks like this. S sub n equals a sub 1 times 1 minus r to the n power over 1 minus r. In this formula, n is the same as this n. It stands for the number of terms that we're dealing with. A sub 1 is the first term in the series, and r is the common ratio, that number that we multiply by each time to get the next term in the series. Now, there are a couple of different versions of this formula, but you'll get the same answer in the end. Now, in order to use this formula, we need to find out what n, a sub 1, and r are equal to. So let's go ahead and take a look at n. Well, we pretty much already know that answer. That's the number of terms that we're dealing with. And if we look back at our sigma notation, n goes from 1 to 8. We're looking for the first 8 terms. So n equals 8. Great. Now that we know what n is equal to, let's go ahead and find the value of the other variables, a sub 1 and r. Well, a sub 1 is the first term, and we could find that by plugging 1 into this right here and simplifying. But there's a little faster way. We actually have an explicit formula for a geometric series. This explicit formula tells us how to find any term in a geometric series. We have a sub 1 times r to the n minus 1 power. Well, if we compare that to what we have 3 times 2 to the n minus 1. Well, matching everything up, we get that our first term, a sub 1, is 3, and r, our common ratio, is 2. Perfect. Now that we have these values, all we need to do is plug them into our formula and simplify. And that will give us the answer that we're looking for. So let's see. We want to plug these values into the formula for the partial sum of a geometric series. So we have s sub n. Well, n we found was 8. So we have s sub 8. This means that we're finding the sum of the first 8 terms in this geometric series. So let's see. This is equal to a sub 1, which is 3, times 1 minus r to the n. Well, r is 2 and n is 8. So we have that. Then in the denominator, we have 1 minus r. So 1 minus 2. Now we just need to follow the order of operations to simplify. Well, in the numerator, we need to take 2 to the 8th power. So when we do that, we get 256. Well, if we take 1 minus that, that leaves us with negative 255. In the denominator, if we take 1 minus 2, we get negative 1. Now in the numerator, we need to take 3 and multiply it by negative 255. That gives us negative 765. And that's still over negative 1. Now if we take a number and divide it by negative 1, all that does is change the sign of the number. So when we simplify this, we end up with a positive 765. This is the answer that we were looking for. This is the answer to this problem, if we evaluate it. So here we have now found this partial sum of the geometric series that we're looking at. We have found that the sum of the first 8 terms of this geometric series is equal to 765.
And we're back. Okay, now let's take a look at these two. So we've got the sum from 1 to 8 of -2 times -5 to the n minus 1. So she went through her sequence with what she had to find. So we still need a sub 1, we still need the r, and we still need to know the n. Okay, she told you the tricky and the quick ways to find those things when they're in this notation, so we don't have to go in there and find a of 1. You're just going to find out, in this case, that the a of 1 is going to be -2. Your r value is essentially going to be your base of what's being risen to the exponent, so our r value in this case is -5, and our n value is going to be 8, because we're looking for the first 8 terms. Now we know the a1, we know the r, we know the n. As long as we do those things, then we can find the sum of the first 8 terms. So then s of n is going to equal -2 times 1 minus -5, all risen to the 8th power, all divided by 1 minus -5. We go ahead and solve this now. So we've got -2 times 1 minus -5, risen to the 8th. All of that divided by 6. We get 130,208. Okay. Let's take a look at one more. Let's look at number 14. So our a of 1 value, our r value, and our n value, the 3 things we have to find. N value is pretty simple, that's 7. Well, what is our ratio going to be now? Our ratio is what's being risen to the exponent. So -4 is being risen to the exponent, so our r value is -4. Our rate, or ratio, I say rate, I meant ratio. Back to whatever. A of 1, there's nothing sitting there, so if I plug 1 in, it's just, a of 1 is just going to be 1. Again, there's understood to be a 1 there. So we've got the sum of the first 7 terms of this is going to be 1 times 1 minus -4 to the 7th power, all divided by 1 minus -4. So 1, clear, don't really need that, I guess, times 1 minus, in parentheses, -4, raised to the 7th, close parentheses, divided by, that's 5, 3,277 is the value for that. Okay, so now that's finding each geometric series using summation notation. Looks a little scary, but it's really not. And she did a nice job of explaining to it, and hopefully you understood that. Last part then we're going to do now, and this is the part that's going to give, that is probably the most difficult part for this. We're going to determine the number of terms in n in this geometric series. So they're giving us the series, they're giving us the sequence to a point, and then they're giving us the sum of them is -1093, and it wants us to find out what our n value is. Okay, so let's think about this. We've got the formula S of n is equal to a sub 1 times 1 minus r to the nth power, all divided by 1 minus r. So let's think about what we know in this. We know the S of n. They gave it to us. Remember, S of n means the sum of. They gave us that. That's -1093. Can we find our ratio? Well, it goes from 1 to -3 to -9, so it looks like it's multiplying by 3. So our ratio is 3. Do we know the A1 value? Yep, we know the A1 value. We know the A1 value is -1. What we don't know right now is we don't know the n value. That's a question mark. But I can fill everything in but one thing. I can fill in the S of n, I can fill in the A of n. So I can fill in this, I can fill in this, I can fill in this, I can fill in that. So that leaves me one unknown. So if I have one unknown, I can probably solve for that unknown. So we could find an inverse here if we wanted to. I could solve that for n, which is, again, kind of finding an inverse, which is kind of what we did when we were, one of the sections in this chapter. Maybe it was last chapter. I don't remember anymore. I think it was 6.3. So we could find the inverse by either plugging in the numbers first, or we could solve for n. If we solve for n, here's a thought. If we just went ahead and solved for n in this case and made that inverse, aren't we going to come up with an equation that we could use every single time? And since you can use your notes on the test, thoughts? Okay, so let's do that. We could find the inverse of this like we did, and then calculate it through using the inverse. That gets a little bit tricky. It's really cool, but it gets a little bit tricky. So instead, we're just going to plug stuff in. So it's not really, I say plug and play, but this is a hard plug and play. So that's -1093. My A of 1 value is -1. And that's going to cause a little bit of an issue. Times 1 minus my r, so 1 minus 3. But I have to take that 3 to the nth power, and I don't know what that is yet. And then I need to divide that by 1 minus r, so 1 minus 3. Now I need to solve this. Okay, so I've got this 1 minus 3 on the bottom. That's -2. So we've got that -2 on the bottom. So I'm just going to keep doing it. -1 times 1 minus 3 to the n divided by -2. So I'm going to multiply both sides by -2. So 1093 times -2 is, so that's 2,186 is equal to -1 times 1 minus 3n. So multiply by -1. So if we multiply by -1, that gives me -2,186 is equal to 1 minus 3 to the n power. And move the 1 to the other side. So that's -2,187 equals -3 to the n. I don't want it negative, so switch the signs. So we've got 2,187 is equal to 3 to the nth power. It's a logarithm. It's an exponential. 3 to the n equals, it's a logarithm. It's exponential. I can write it as a logarithm to solve. Cool beans. That's log base 3 of 2,187. That's going to be my n value. So that's the log of 2187 divided by change of base formula. Log of 3 equals 7. So n equals 7. If you watch the blooper reel at the end of it, if I put that at the end of it, we found the inverse, and that's what we got. We got the same answer by finding the inverse. Math is so cool. Sorry. You don't know if I'm talking about, because you probably won't watch to the end of the video, so you probably won't watch it either. But if you're interested in the inverse, in a really cool thing that happens, got excited by math. You watch the end, it's really going to be long too, but whatever. Math is so cool. It works. And what happens when you use the inverse is you can use that formula all the time instead of doing it, but whatever. So be it, whatever. Okay? Sorry, got excited. All right, let's look at one more of these, because I think these are really kind of quite difficult, so we should probably know how to do them. So let's look at one more. So we've got negative 2, minus 12, minus 72, minus 432. And my S of n value, because we want to make it fun, my S of n value is negative 6, 7, 1, 8, 4, 6. We're going to find the n value of this, okay? So start out by listing what we know. We know our S of n value. Maybe you don't need... so we got our S of n value. I'm not going to rewrite it. It's too long. It's right there. So that's my S of n value. I can find the ratio. Negative 12, so it's 6, right? Yep, just multiplying by 6. Negative 2 times 6 is negative 12. Negative 12 times 6, so my ratio is 6. My a of 1 is equal to negative 2. We have to find the nth value. So we can use our formula. My S of n, change colors. Let's make it burgundy this time. So we've got negative 671,846. S of m equals a of 1, so negative 2 times 1 minus my rate, which is 6 to the nth power, all divided by 1 minus 6. Okay, so can we agree that it's negative 5 on the bottom? And then we can multiply that negative, so we can take 671,846 times negative 5. Well, they're both negative, so it's going to be positive. So that's 3, 3, 5, 9, 2, 3, 0. That's equal to negative 2 times 1 minus 6 to the nth power. Going to divide by negative 2. That's 1, 6, 7, 9, 6, 1, 5 equals 1 minus 6 to the nth power, because we divided by negative 2. So that should be negative, right? That should be negative. Yep, that should be negative. Going to subtract 1 from that. So that's negative 1679616 equals negative 6 to the n. We're going to get rid of the negatives. So that's 1679616 equals 6 to the n. So that's log base 6 of 1679616 is going to equal n. Cool beans. So the log of 1679616 divided by the log of 6. With any luck, we get a nice answer, and we get 8. Gosh, math is so cool. So there are 8 terms in that sequence. Now, if we wanted to find out what the 8th term was in the sequence, could we do that? Sure. From up above. But anyway, so that's math. Math is cool. Okay, video lasted a whole lot longer than I probably wanted it to, but if you, depends, I guess, and probably if you don't watch the inverse part of it, it's not that bad, but the inverse part is cool. So, I mean, you're looking at like a 37-minute video and a little bit long, but we stretched it a day. You've got some time. If you were in class and you did this in class with me, it's how long it took you, because we're going to do the inverse because it's just cool and it works, and it's fun. So, see, math can be fun. Watching me on video doing math when I'm having fun might not be so fun, but math is kind of cool. It kind of makes things work. I was walking by the science rooms the other day, and science only works because of math. Okay, you could say that the only reason you need math is for science, probably too, and that's what some of the math teachers would say. It's the only good use for math is science, but science doesn't work without us. So they need us more than we need them. So take care of yourself, everybody. Hope you enjoyed the video. I don't know, subscribe if you want. Hit a like button every once in a while. Makes me feel good about myself when I see a thumbs up. I don't know. Have a great day, everybody. We'll see you next time. I'm going to solve this for n. Well, the first thing I'm probably going to do is I'm going to take S of n times You know what? That's kind of a thought, but it's not going to be the easiest thing to do. I mean, we could do it. We would go S of n times 1 minus r. That's going to equal a1 times 1 minus r to the n. Okay. I'm going to divide by a1. So we've got S of n times 1 minus r divided by a of 1. That's going to equal 1 minus r to the n. S of n times 1 minus r, all divided by a1. If I subtract 1, that's going to be r to the n. Yeah, so you can see, I mean, really now I've got something to an exponent equals something. So realistically, we're probably not going to do this, but I could write this as a log. I could write this log base r of S of n times 1 minus r, all divided by a of 1. That has to equal my n. That works. And you got to remember, all these things are numbers. R is a number, S of n's a number. We've already found all of those. So, we could, and those of you that are at home, this is not as much fun as we're having in class doing this. I promise you, this is not as much fun doing it this way with you guys that are at home as it is for the ones that are in class right now. I might try finding a way to do this so you can both do this in class. Maybe it's not fun if you're in class either. I don't know, but it's kind of cool. Let's see if it works. Log base r. So we've got log base r. So we've got log base 3 of S of n. So that's negative 1093 times 1 minus 3, because my r is 3. All of that divided by negative 1. Oh, shoot. We missed this right here. That's got to be a negative. So that's going to make all of this negative. My bad. We should have divided by negative 1 and made all that negative over there. So this has to be negative right there. Missed that. All divided by negative 1. That has to equal my n value. So that's log base 3. I got to figure out what all that mess is. I've got a negative sitting there. Negative. Log. Clear. Log. No, clear. What am I doing? Negative 1093 times negative 2. Divided by negative 1. Okay, and then a negative, that's where we're just going to make it positive. So that's 2,186. So if I go the log of 2,186 divided by the change of base formula, log of 3, I get 7. Because we got the negative and the negative. So I'm just going to make that positive, distribute that in there. Blah, blah, blah. So we got positive. So you get n equals 7. Actually, math is kind of cool. That worked out to 7. All that mess that we just did, all that worked out to 7 by doing the inverse, which is something we learned how to do. I forgot the negative, but we fixed it. 7.